So, a reminder before the lesson begins, make sure you're taking notes and you're listening and watching for the keyword or phrase.
Let's get to it.
So, today we're going to be talking about lesson 7 in unit 4. Our aim is how do we solve multi-step equations with variables on both sides of an equal sign? So, we're going to be talking about isolating your variable, a lot of different concepts that we've learned in the past years, as well as last lesson, number 6. I'll include that at the top of the video. Just going over how to write two-step equations and what basically creates an equation. You have your variable and you're determining the variable from the word problem. You're determining your coefficient that's going to match up with your variable, what's going to change or how it's going to change based on your variable. Determine the constants, what something's going to be equal to, what's staying the same. Writing your equation and making sure that you're isolating your variable because you're solving for a missing piece. And that's what your variable represents, an unknown value. So strategy that I talk to my students about and I share, and probably you've heard in the past or maybe somewhere else, is DCMAM, which is basically a way to help you remember the different steps when solving multi-step equations. So the first step, D, is the distributive property. So you want to make sure that you're distributing where you can. And sometimes the first two steps combine with each other because you want to make sure you're looking to combine your like terms. So sometimes your like terms will be in your parentheses before you distribute. Sometimes they'll be afterwards. So you always, in basically every step I tell my students, you want to make sure that you're combining your like terms or looking for those like terms in order to identify when you have to combine. Your next step is to move your variables to one side. This is just my suggestion. Again, you might have learned a different way. Move your variables. And you want to make sure that they're on one side. The whole idea is to get your variables on one side and your constants on the opposite side in order to then isolate your variable. So my suggestion to my students would always be to move your lower coefficient. So if you have a negative value versus a positive value, you want to move your negative. This way you avoid using negatives. But again, if you're comfortable with using negatives, then go ahead. You can move either coefficient that's matched up with the variable that you're trying to move. Again, the end goal is to isolate the variable. So you want to get variables on one side and then constants on the other side. After you move and separate your variables and constants, you want to make sure you're, again, adding and subtracting constants depending on isolation. So whether they're on one side that you need them to be or not. And again, sometimes you just need to move one or two things. Maybe you don't even need to move the constants in an equation. And then the last step is to make sure that you're multiplying and dividing to isolate your variable. And the whole idea is to solve for that missing variable, the missing value. So in order to do that, you have to either multiply or divide depending on the inverse operation in order to solve for it. Okay, so let's try out some guided practice problems. All right, so the first guided practice problem, the first thing you want to find or what you want to do in order to solve is distribute. So we have 5 times x, 5 times your negative 12. Again, following the same procedures and steps to distribute. I'm going to put my line down the equal sign. I have 5x minus 60 equals negative 105. So that's my first step. Now it looks like I just have a two-step equation. So what I'm going to do afterwards is I'm going to move my constants because I don't have to move any variables. My constants have to go from the left to the right in order to isolate my variable because I want to get x by itself. So I'm going to add 60 because that's the inverse operation to both sides. These are going to cancel out. I'm going to get 5x on the left equals negative 45. I'm still isolating my variable, so that means I have to separate my coefficient and my variable using inverse operations, and since they're being multiplied, I have to undo that and use division. And I want to divide by what I want to get rid of because they're going to cancel out. That means I have to divide by 5 on the other side and get x equals negative 45 divided by negative 5 is going to give me negative 9, and that is going to be my answer. So x equals negative 9. And I can always check my answer. So in order to check, I can just substitute what I got for x into my equation. So negative 9 minus 12 equals negative 105. And the whole idea of checking your answer in the original equation is to make sure that both sides balance out. So I still want to make a line down the middle. Negative 105 is going to stay on the right. What I'm just going to simplify is my left side. And the first thing I want to do is figure out what's going to happen and simplify starting with my order of operations, which is parentheses. So I have negative 9 minus 12. I'm going to get negative 21 times 5. This is going to equal negative 105. It should equal negative 105. That's the whole idea. Actually, I'm going to get rid of this so you can see this better. Okay, so 5 times negative 21 is going to give me negative 105. And as long as that balances out on both sides, you know that your answer of negative 9 that you substituted in is correct. So this is how you ensure that you have your correct answer. Number 2, pause the video, try this one on your own, and come back and check your answer. So here I see that we have like terms on your right side. So I want to make sure that I combine those first because there's nothing that I have to distribute. So I have 44 on my left. 3m plus 4m is going to give me 7m. Negative 8 minus 4 is going to give me negative 12. And here I am with my two-step equation. So the next step is I'm going to add 12 to both sides. This is going to cancel out. I'm going to be left with 7m, and then I'm going to be left with 56 equals 7m. I need to still isolate my variable m, so that means I'm going to take my inverse operation, and I'm going to divide by 7 on both sides, and then I'm going to get m equals 8. And in order to check my answer, I'm going to take my original equation and substitute in 8 every time I see m. So this would be 44 equals 3, 8 minus 8 plus 4 times 8 minus 4. And here we have just another way of checking our answer. So I'm going to simplify everything. 44 stays the same on the left. 3 times 8 is going to give me 24 minus 8 plus 32 minus 4. And now I can just follow my order of operations and simplify left to right. 24 minus 8 is going to give me 16 plus 32 minus 4. And again, I'm just going through every step. 16 plus 32 is going to give me 48 minus 4. And then 48 minus 4 is going to equal 44. So this checks out. That means 8 for m is going to be correct because I'm substituting 8 everywhere I saw m in my original equation. I'm not solving again. I'm just making sure that this right side will balance out and equal this left side. Obviously, if I got a different answer on my right, when I started simplifying everything, I knew that my answer would be wrong. So I can always go back and fix that. All right, Number 3. So number 3, you're solving for y. Pause the video here, try it on your own, and come back and check your answer. So for number 3, I'm going to distribute first and get rid of my negative on the outside. So I'm going to distribute to inside of and get 6y minus 5 equals 20 plus 2y. So here on my left, I have to combine my like terms. On my right, there's nothing else that I have to combine because they're different terms. So I have 6y minus y. I get 5y minus 5 equals 20 plus 2y. So what I notice is that my 2y, my lesser or lower, well, not lesser, my lower coefficient is going to be positive 2. So I'm going to subtract 2y from both sides to isolate my variable. So this is going to cancel out. I'm going to be left with 20 on the right, and then I have 3y minus 5 on the left. The only thing that I have to now get rid of is my constant. So here what I'm going to do is I'm going to add 5 to both sides. This is going to get rid of my constant on the left, and I'm going to be left with 3y. And then I have 25 because 20 plus 5 is going to be 25. Still isolating my variable, I'm going to divide both sides by 3. Y is going to equal 8 and 3 repeating. Or what I can write is y equals 8 and 1/3. So again, if we check our answer, we're substituting 8 1/3 everywhere we see y. So every place that we see y, we're substituting that in. So we are going to get 6 times 8 1/3 minus 8 1/3 plus 5 equals 20 plus 2 times 8 1/3. So continuing to simplify, 6 times 8 1/3, you're going to get 50 minus 13 1/3 equals 20 plus 16 2/3. So what we're going to continue to do is simplify on either side, not solve for anything, not combine anything, just continue to simplify on both sides. Okay, so if I do 50 minus 13 1/3, I am going to get 36 2/3. And if I add 20 plus 16 2/3, I'm also going to get 36 2/3. And I know that they balance out, they are equal. And I know my 8 1/3 would equal y. And that would be my correct answer. Again, always check your work to ensure that you're going to have the correct answer, especially if you solve for your variables. Make sure you're moving your variables to one side, your constants to another side in order to isolate your variable using your inverse operations. Check the keyword or phrase for the lesson. Always write down your questions for me. Make sure you're practicing your questions, do your homework, practice on your notes, and I will see you in the next video. Bye.